In this work, we present AnyDoor, zero-shot object-level image customization. This work is completed in cooperation with the University of Hong Kong, Alibaba Group, and Ant Group. AnyDoor introduces an image editing tool with fancy applications. This model is called AnyDoor because it could teleport an object into the given background image, just like the fantastic magic tools of Doraemon. It is the first zero-shot method to achieve this function. As shown in the first row of the demonstrations, AnyDoor supports users to place an object at specific locations with optional shape controls. It can be extended to handle multiple objects, like in the middle row. It can also support seamlessly editing the shape of the object or swapping objects within real scenarios, like in the bottom row. Our AnyDoor model is developed based on the diffusion model. First, we introduce the basic concepts of the diffusion model. The diffusion model views the image generation process as a multi-step denoising process. We consider that by continuously adding noise to a clean image, it can be transformed into a Gaussian noise. The reverse of this process is the generation process, where we start from Gaussian noise and gradually predict and remove small amounts of noise step by step to obtain a final clean image. The core idea of this model is decoupling the object representation into the global and the local perspectives. We use self-supervised models like DynoV2 as an ID extractor to encode the global identity of the target object. At the same time, we leverage the high-frequency information as a supplementary guidance to recover the fine details. This global and local information are injected into the diffusion model to generate the target object in the given location of the background image. In order to make diversified and harmonious generation, we prepare the training samples from video streams to capture the different states of the same object. Next, we dive into the specifics of each module. First, we use DynoV2 for feature extraction of the target object. The DynoV2 view module possesses strong and robust representation capacities, which allows for better categorizations of objects, especially for the representations of the identity for all common objects. Then, we use high-frequency features to supplement the details of the target object. We found that directly pasting the original image of the object onto the background results in the severe copy and paste effect in the generated output. Therefore, we designed an information bottleneck that retains only the high-frequency information of the object. The design of the data collection strategy is also a crucial aspect of AnyDoor. Previous method segment objects from static images and paste them for training, resulting in the lacking of diversity in the generated outputs. To ensure the diversity in terms of the pose, lightings, and other aspects, we collect samples from video and 3D dataset. Specifically, we track the same target in videos, identifying samples of the same object at different times in different status for training. In general, the contributions of AnyDoor could be summarized in threefold. First, we collect image data pairs from video. Second, we use more discriminative self-supervised representations to extract the global identities. Third, we add spatial level details by adding the high-frequency features to supplement the fine details. We compare AnyDoor with previous methods and found that earlier approaches could only retain coarse grain features, such as colors and the category, but could not preserve the identity. In contrast, AnyDoor can maintain very detailed features and naturally blend them with the background. We conduct ablation studies for the choice of ID extractors. We find that DynoV2 shows significant better results compared with other ID extractors like the VGG network and the clip image encoder. We also compare different forms of detail maps. We find that the high-frequency maps get a good balance between the fine details ID preserving and the generation diversity. We demonstrate the generation results using different kinds of training data. Only using image data causes the lack of diversities. With the help of video data, AnyDoor gets a good balance between the ID preservation, and generation diversity. AnyDoor could teleport the given object into the new scenarios, and at the same time we can choose to control the shape of the generation result by given masks. AnyDoor could also be applied into some practical applications, just like visual try-on. We hope that AnyDoor can become a foundation model for local image composition, supporting a large range of downstream tasks. Thank you.